Hello and welcome to this video on IP addresses. If you haven't already seen any of my other videos, I'm Otis Stubbs. This is my YouTube channel where I explain networking concepts. Check out some of my other videos. I recommend you watch at least my introduction to networking and the video on the OSI model. If you don't know what either of those are, then definitely check that video out. So in this video, we're going to go into a little bit more depth. It's still going to be a very basic, fairly short video, but we're talking about IP addresses. Okay, so I've already sort of brought some stuff up. I'll explain what this all is. I'm just trying to keep it organized. Otherwise, I'll just rant on for hours and we won't get anywhere. So I'll explain what this all is. Here's the agenda. Okay, so let's get to the first thing, which is what an IP address is. So here's an acronym. It's the Internet Protocol, right? Internet Protocol. You've probably heard of an IP address, and it's pretty much just, a bit of information when we're talking about. If you don't know what I'm saying here, then watch that other video on the OSI model. When we're talking about encapsulation, right, it's a bit of, it's a header that gets added to the data, and it's useful. It's pretty much useful metadata that will tell us about where we're going. So the reason it's useful is that, just like in the postal system, when you're sending a parcel, you need to know who it's come from and who it's going to. Same idea with the IP address, right? In this metadata, in this header, there'll be a source and a destination address, and pretty much all it's doing. There's some other fields for other stuff, but pretty much it's just saying who is it coming from, this packet, who is it going to. Okay, so let's look at the format of the address. Sorry for that noise. In the format, we've got x.x.x.x, and where there's an x, we're going from 0 to 255. So there's a lot of combinations with all four of these blocks. With that range, there's about 4 billion combinations. Lots of different addresses, right? And we always pair the address with what's called the mask. And essentially what the mask does is, as you can see here, under each address I've written the mask. What the mask does is say where there's a 255, that portion is showing you what the network is. Where there's a 0, that portion identifies the specific host. So you notice with all these, I'm just drawing these lines to separate. I didn't draw them quite directly under each other. Where there's the 255, right, that is the network, and they're all on the same network, so they all have 192.168.1. On the other side, where there's the 0, that identifies the host. This is 1, this is 2, this is 3. So the mask is always paired with the IP address. That's how the protocol was designed to work. Okay. Now, what happened is we started to run out of IP addresses, and 4 billion sounds like a lot. But there were just devices like light bulbs that were needing IP addresses, and so we started running out. And so there were some temporary fixes. I'm not going to get into them now, but there was what's called network address translation, NAT. There was a document that came out that specified certain private IP addresses. Okay, and there was, there's some other, some protocols and ideas that were developed to overcome the shortage in IPv4. When we talk about IP, we're usually talking about v4. Some temporary fixes that actually have ended up becoming more than just temporary. Like, we still use a lot of these things. But the better solution, or the solution that, people hope, or some people are kind of divided on this topic, but we hope that we'll end up moving to this IP version 6 completely. And the benefit of this is that the address range, instead of here, you get 4 billion combinations with, because it's in binary, 2 to the 32, right? That's just an exponential little thing here, 2 to the power of 32. And the reason is because this number, when you actually represent it in binary, is 32 numbers that can either have 2 values, which is why we've got this little statement here. With IPv6, it's also going to be in binary at the end of the day, although we might represent it in decimal. It's 2 to the 128. And that is actually a lot larger than 2 to the 32, because it's exponential. So this number is massive. And the idea is that we'll never run out of these addresses. So although there are some temporary fixes, people hope that eventually we'll just use IP version 6. Okay, so yeah, we've covered what this video. It was just a short video, little explanation. Hope you learned something new. Check out some of my other videos. Have a good day, and I'll see you later.